This is part 2 of section 1.3, functions. We want to determine whether each of these functions that we're going to be talking about defines y as a function of x. So what we're going to do is we're going to solve these equations for y. Because remember, if we have y equal to, we have a relation, and if it's a function, then we can replace it with f of x. What we're looking for is when we solve it for y, we don't want any possibility of getting more than one answer. So in other words, for us, we don't want to end up with a plus or a minus, okay? Anything that makes us get more than one solution, we've got a problem. It's not going to be a function. All right, so let's come back up here and look at x is equal to the absolute value of y. So what we do when we have the absolute value equation is we split it up into two problems. First, it's, sorry, I wrote that backwards. X is equal to y. First, you drop the absolute value, or x is equal to negative y. When you have an absolute value, you get the absolute value by itself, you split it into two problems. So here, I've got this, and then if I solve this one for y, this one already is, I get y is equal to negative x. So when I solve this for y, I either get x or I get negative x. The only time these are the same is when x is 0. For the vast majority of the time, you get more than one answer. So if I plug in an x value, I can get more than one y value. So this is not a function. Okay. Now, I'm going to be looking ahead a little bit here. I'm about to show you something that we will be learning a little bit later, but I'm going to go ahead and make the connection for you, so hopefully it all ties in together for you later. We don't know, we haven't talked about the graph of these things yet, and that's a little bit in the future, but this graph is going to look like this. Okay, and we're going to be talking about how to identify functions from graphs, and if you can keep this in mind, all of this will be a little bit more clear later. Okay, now let's try the same thing here. X squared plus y squared is equal to 8. I want to figure out if this is a function or not. So I need to solve this for y. So to do that, I'm going to subtract x squared from both sides to get y squared is equal to 8 minus x squared. And now to solve for y, I can use the square root property and take the square root of both sides. But when we take the square root of both sides, or actually any even root of both sides, we have to add the plus or minus. So we get y is equal to plus or minus the square root of 8 minus x squared. Again, we got a plus or minus when we solved it for y. So this is, again, not a function. Okay. And again, we haven't talked about this yet, but this is a circle. And when we start talking about the graphs of functions, we'll be able to come back to this. Okay. Now let's look at this one. This is similar. X squared plus y cubed is equal to 5. So I want to solve for y. So I'm going to subtract x squared from both sides. And I get y cubed is equal to 5 minus x squared. Now I need to get rid of this cube. So I'm going to take the cube root of both sides. Okay, but I do not need a plus or minus. Now, I said this earlier, but to drive it home, if the index, that's what this number is called, is even, you need a plus or minus. So if you take the square root of both sides, you need plus or minus. If you take the 6th root of both sides, you need plus or minus. But if it's odd, you don't. There's only one solution. So this is y is equal to the cube root of 5 minus x cubed. Okay? And this graph would look something like this. Wait, no, like that. Doesn't matter too much, but that basic shape. Okay?